Developers, like anyone, can only get better at what they do if they have some way to measure the success of their achievement. Amy DeMartine explained how a closed loop is important in DevOps, the ability to provide insight back to the developer about their application in production. Security insight is super valuable, while being able to stop attacks is even more so. GitLab's newest stage, called Defend, does just that, especially for cloud-native applications. So as I pointed out in my book last year, with cloud-native, you have additional attack surfaces to consider, such as containers and orchestrators. Nico Meisenzahl from White Duck, together with Philippe, Lafoucrière, and Wayne Haber from GitLab, will do a little role play to share how this works with Kubernetes. And remember, you can always ask them questions in the chat. Enjoy.
So, hello everyone and welcome to our talk, Your Attackers Won't Be Happy, how GitLab can help you to secure applications. Before we do a quick intro of ourselves, just a note, if you have any questions, just put them into the chat and we will do our best to answer them. So, my name is Nico Meisenzahl. I'm Senior Cloud and DevOps Consultant at White Duck. White Duck is a company based in Germany. We're doing cloud native application development and consulting, mainly focused on Azure. So, Philippe.
And I'm Philippe Lafoucrière. I'm a distinguished engineer at GitLab based in Canada. Wayne?
I'm Wayne Haber. I'm Director of Engineering at GitLab, working on leading the threat management team based in Georgia, USA. So we are going to do various roles in this, where Nico is going to be the application developer, developing the application that happens to have a security bug. Philippe is on the security operations team, and I'm going to be the attacker.
Okay, so give me a short overview about my wonderful application. So it's a pretty small one. We containerized it, so it's actually running in Kubernetes on Azure. So it's running in Azure Kubernetes service, which is the managed offer of Azure. The app itself is based on Go. So it's a small Go app serving a web interface. In the web interface, I will demo it in a sec. There's an input field where you can put in an IP address or hostname. And this input then gets pinged by the application executing the ping CLI with the IP address, then collecting the output and presenting it back into the web interface from the application. Do a small demo. So this is the application. As I said, small input field. Just go for localhost here, push the go button, and now the application executes the command. We'll get the insights here again, and we get the output. So we just pinged localhost, so we pinged ourselves. We got the output, everything is fine. So looks good.
All right, so now I'm going to talk about exploiting the application. So as Nico mentioned, the application allows you to ping something, ping an IP address or a host name. And generally, you just give it a host name, and then it will ping it and provide the result. But it turns out, and I'll show this, the application doesn't validate the input. So it's running executing ping, and then the whatever you give it as the string. So in addition to a host name or IP address, you can actually put a semicolon and then any Linux command. So I'm going to show, and what I'm going to do is actually connect to Redis and make some changes to the Redis data store, which should not be allowed. First thing it is, I'm going to do what Nico is. I can, let's say, ping 127.0.0.1. Say, aha, that's interesting. I can see the ping output. I wonder what happens if I put a semicolon and then run a command like uptime. What happens there? Well, here's the ping result. Ah, it's letting me run a command with the semicolon. So it's got a command injection problem. I can also do something like run, let's see here, say localhost, and I'll redirect that to dev null, so I don't see the ping result anymore, and then say, who am I? Oh, that's nice to see. I'm actually running as root. So let's see what's going on with Redis. So I'm actually going to run a command and see if I can get a list of keys in Redis. So again, localhost, redirecting to dev null, and then run the Redis command to get a list of keys. Well, that's interesting. User 0, user 2, user 1, key 0. Let's see what's in key 0. So can I actually not only get a list of keys, I can get a specific key. Look at that, it's got a value in it. Let me see if I can set it. So I'll say set key 0 and L33T. Well, came back as okay. Now I'm going to get that again. Get key 0. Oh, wow. I was able to not only read data out of the database, but also data store, but also set some data. So I may have more nefarious things planned, but that is what I've got so far. Now I'll turn it over to Philippe.
Philippe, exactly. So at this point, we start getting some notifications and some complaints around this application. So I will start by opening the threat monitoring page of this project on GitLab. And as we can see on this page, we have an unusual amount of anomalous requests. That's not the total number of requests that we have. So there is something suspicious going on there. So what I'm going to do is I'm going to jump directly into a terminal and check the logs of our Web Application Firewall. So to do that, I'm going to use the kubectl command, and I'm going to extract the logs that I need in the GitLab managed apps namespace. We want to have the logs of the Nginx ingress, sorry. And we want that for the component. That is a controller. We also want to check the logs of the mod security log container. That is a sidecar to ingress. So we see that we have a lot of things here, probably too much detail. So let's grab a bit on the host that we're looking into. Oh, it's up. Never mind. I hope we will be able to cut that out. Sorry for that. So from there, I'm going to follow everything that is occurring in there and see if we can get something relevant related to this attack. That's interesting. As we can see here, I can see something related to Redis here in the log. So I'm going to make that a little bit easier to read. We're going to use fgrep for that because I want to pipe that into JQ. We're going to actually grep on the host. Up.commit something. And I'm going to use JQ for that. So that's interesting. We have something in the logs that the Web Application Firewall codes, but actually the Web Application Firewall is in logging mode. So we're just logging some suspicious traffic in there. So I can see there's a remote code execution ongoing on this application, and the value is apparently something related to Redis CLI. So at this point, we're not sure yet that the remote command execution actually occurred on the pod, on the container. We know that it went through the Web Application Firewall directly to the application. So it's time to check something else. We're going to use another feature from GitLab named the container host security. And I'm going to check the logs of this application to see if something was executed or not. This is something that we can detect with this feature. So I'm going to use the GitLab managed apps namespace again. I want to grab the logs, and this time we're going to use the app named Falco that we're shipping with this feature. I want to have something recent, so I'm going to use this, and this time I can grep directly what I'm looking for. And the third, and we're going to grep on production app because that's the name of the pod that we're using in this. So I have nothing here, but if something weird happened, like, oh, there's another attack happening. So I can see in the output of Falco here that we have an error that is raised to my attention. A new process has been spun up in the application controller. This is actually bad because this process is running as root, and I can see that the command is even worse than that. It's ready CLI, and it's hitting a pod that is not even in the same namespace. So at this point, we know that something really bad is happening. Redis is often used as a queuing system storage, so the potential of the attack might extend to at least another application with maybe some data leakage. So we have 4 problems here. The first one is we have an insecure application that has been deployed to production, leading to this security hole. The second one is the application allowed to execute some remote command and as root, so it's even worse than that. We're not obviously blocking any suspicious or malicious requests at the Web Application Firewall level. And last but not least, the application could hit another namespace. We have here east-west traffic, and it's not controlled properly. So we need to remediate to all of this, and we need to see this vulnerability in its whole in the global environment. And that's where GitLab is really ending. I'm going to share my screen again here. Saying the problem is not only the application. The problem is the application in its whole environment. So it's not enough to just fix the problem that we have right there with this ping command. We might have any other security hole in the application, and that will lead also to some east-west traffic. So first of all, we need to use what we call GitLab Secure, which is composed of SaaS dependency scanning, container scanning, and even DAST, and a lot more features that are upcoming to secure the application before shipping that application to production. Right after that, we need to extend our protection to another layer with container host security. This is what we've seen where we are able to detect events based on rules that are deployed by GitLab. And this kind of events can detect spawning processes, for example. And we even have the ability in the latest version of GitLab to block these processes from being spawned. And last but not least, we need to operate at the network level. So here we're going to use 2 features of the container network security offering from GitLab. We're going to use the Web Application Firewall, and we're going to use network policies to control this east-west traffic and to disallow this pod, this application that we've just seen, to go outside of his namespace. So I'm going to hand over to Nico. And Nico, I would ask you to not only implement a blocking WAF, but also to put in place the network policy so that this application won't be able to hit this Redis server again, and obviously to fix your application in a timely manner. Up to you, Nico.
Sure. So let me share again my screen. So we now heard about how we can fix all the issues and prevent those again. So let's have a look how we can enable and activate this in our GitLab project with GitLab. So once again, we are in our application project here. On the side, Philippe already showed security and compliance, threat monitoring, where we see our Web Application Firewall enabled, which is actually at the moment in listener-only mode, so it's only logging. And we also have our container network policies where we also see our packages without any drop packages so far. So if we go back to our test application and try to inject something again, it still works because we do not change anything. But now if we go on this side to the policy tab above here and switch on one of the default policies, in this case, this one here, which basically allows only ingress traffic for all GitLab managed apps and completely denies egress traffic. And we enable this one and apply this change. We now should be able to block the execution of Redis CLI, actually not the execution itself, but the Redis CLI won't be able to talk to the Redis master pod in the Redis namespace anymore. So if I now press go, the application is just loading until it gets in timeout, because the connection between our pod and the pod in the different namespace got blocked. So now it's a timeout. We only get a white page. If we go back to the overview page and reload it, we actually should see in just a second, or already see the details here in the output. Okay, so it will some more seconds until we see it in the UI. But as we already saw, the request got blocked. So, but still, the tag is already within our container. So it might be somewhat better to try to block it in front of our cluster or at the outer solution. So with this, we can use the Web Application Firewall, which we already enabled, and just put it to blocking mode to make sure that the whole request gets blocked. So this can be done in the Kubernetes integration of your project or your group. In our case, it's in group. So I just go to my group level, to the Kubernetes page, select the Kubernetes cluster, and then went over to the Applications tab. And here, we're actually seeing that ingress is installed, the Web Application Firewall is enabled, that is running a locking mode. And here we can now say, okay, let's go for blocking mode. Save this. This will now change our configuration in the cluster. So it will need some minutes to change this. So let me go back to something different and jump back to this in a second. So on the other hand, we now have blocked all the requests, which is pretty good so far. But of course, we would like to somehow fix the issue, to not only block the issue, but really fix the root cause of the issue. Therefore, we can go back to our application directory under the security and compliance tab on our security dashboard, where GitLab already found some issues on our application code. So in this case, we have some error handling issues, which are not good, but maybe not related to our issues. But we also have a medium issue here, subprocess launch with function calls as argument or CMD argument. So somehow might be related to our issue. So let's have a closer look in here. Software constructs all or part of the OS command using externally influenced input from an upstream component. Looks basically like we had this issue here. It got checked from GitLab scanning. We also see the file location. So it's in our main Go file on line 37. So let's have a look. Oh, here we go. It's jumped into our code to the execution line. And we now know, okay, somewhere something within this line needs to be updated, has some security issues. We need to fix it. Of course, we might need to talk to my colleagues, might not be able to fix it on my own. So let's go ahead, go back to the page, and let's create an issue for this to be able to fix it pretty soon. So with this, we also find some of the root cause and be able to fix it. But now jump back to the Kubernetes cluster. Here we see the ingress got updated. We are now in blocking mode. And if I go back to my application, just reloading it, and again, trying to inject the Redis CLI here, we now get a forbidden from the Web Application Firewall. So the whole request got completely forbidden on the Kubernetes ingress on the first stage before hitting the cluster at all. So pretty nice.
So thanks, Nico. What we talked about here is really employing defense in depth. So you want to design applications for security. So perhaps this application should have been designed to make sure that the input was validated. Check the code for security issues, which Nico showed with the SAST scanner, showing the result of the SAST scanner, finding the issue. Other issues could have existed as well. And also what Philippe showed in terms of monitoring for attacks. So with container network policies, with host and application logs, and also cloud provider logs, which we didn't show, but those can be very useful as well. We also want to make sure you're responding to attacks. So what did the attacker do in Redis? What commands do they run? What actions should be taken? Restore the data from backup, isolate the pods for forensics, and potentially more things. And also determine root causes and take action to avoid recurrences. So implementing network and host policies to be default deny, rather than default allow, and default deny and only allow the things you know that should be allowed. Doing root cause analysis of any security issues and fixing the security issues at their source in the bugs, but also doing developer training on security so they understand what the top security risks are and how to avoid them in the first place. The big takeaway from this is that the bad actors only need to find one way in, and the protectors need to protect against everything. So thank you, Zamir, for helping with the demo environment. We also have some links here to the demo app and some of the features we showed, and also to White Duck. And again, as Nico mentioned, if you have any questions, we'd love to hear them. And Nico and Philippe and I are available. Just please put them in the chat. So thank you.